A car left an intersection and traveled east at 32 miles per hour. Another car left the same intersection at the same time and traveled west at 48 miles per hour. How long will it take before the cars are 160 miles apart? So you set x to the time amount spent, and since the one that traveled east went at 32 miles per hour, so you put 32x, and the other one traveled at 48, so you put 48x. And then you set it equal to 160 because it's how far they are apart. And if you solve the equation, you get that x equals 2. So therefore, it will take them 2 hours before they are 160 miles apart. And look, there's a car.
Jeffrey can walk 17 inches in the same time that it takes his pet snail to slide 9 inches. If Jeffrey can walk 4 inches per hour faster than his pet snail, how fast does it take his snail to slide? Well, you set x plus 4 equals to the speed of Jeffrey in inches per hour, and x of the speed of his snail in inches per hour too. Using this data, you can create a chart that puts Jeffrey and his rate, x plus 4, his distance, 17, and his time, 17 over x plus 4, because time equals distance over rate. His snail's rate is x, and the distance that his snail travels is 9. So you put 9 over x. Using this data, you can create a proportion, which would equal to 9 over x equals 17 over x plus 4. After you cross multiply, you get 9 parenthesis mark x plus 4 other parenthesis mark equals 17x. After you multiply this out, you get 19 plus 36 equals 17x. And if you do the math, you get 8x plus 36. And if you divide that out, you get x equals 4.5. So therefore, Jeffrey If you thought that the previous problems were hard, then wait till you see this one. This is the challenge problem. If Jeffrey traveled 300 miles south from his house, then stopped and traveled 400 meters to go east to go to Walmart, how long would the imaginary line from his house to Walmart be? Also, if Jeffrey flew on an airplane from his house to Walmart, what angle would he have to travel at? So, this is assume that this is his house over here, and he travels 300 miles south and 400 miles east. So using this data, you can use the Pythagorean theorem, which if you did it and solved it, you would get that it equals to 500. Therefore, the imaginary line would be 500 meters long. But wait, we didn't answer the second part. Okay, so here is the imaginary triangle that I just made. The adjacent side would be here, the hypotenuse, and the opposite. And since we are trying to find the angle over here, we would have to use sine, which is opposite over hypotenuse, which you would get that sine equals 400 over 500, and therefore it equals to 0.8.